So today we'll focus our attention on integration of rational function by partial fraction. Okay, integration of rational function by partial fraction. So the goal is this: at the end of the lesson, you will be able to integrate any rational functions by expressing it as a sum of partial fractions that we already know how to integrate. So for example, I want you to solve this. Okay, let's say if I give you, let's look at one example, simple example. So I'm taking you to high school algebra. Okay, forget about this integration at the moment. I just want you to recall high school algebra, and if I give you, for example, x minus, I mean 3 over x plus 2 minus 2 over x minus 5. Can you simplify this? Let us quickly review high school algebra. Simplify. So I want you to simplify that. So if you simplify, what you're going to get is x plus 2 and minus 5. And so you're going to get 3 and x minus 5 minus 2 and x plus 2, right? That's how we simplify it. And this is going to give me 3x minus 15 minus 2x minus 4 over x squared minus 5x plus 2x minus 10. So if I simplify further, I'm going to get x minus 19 over x squared minus 3x minus 10, right? So I can write this equals this. So I split the given rational fraction into two easy fraction, simple fraction. And that process is called the, these are called the partial fraction. So these fractions are called partial fraction for the given rational fraction, this one. Okay, they are partial fractions, are these two guys. Now, if you are given integration, for example, if somebody give you integration like this, then the substitution, think for the substitution rule. Substitution rule is not going to work here. Okay, you can try that by yourself. Substitution rule does not work. So what you can do in this case is that somehow, if you know that this fraction is equal to this two fraction, you can write this as 3 over x plus 2 dx minus 2 over x minus 5 dx, right? You can write that. Or you can do this way, this minus 2 over x minus 5 dx. So you can write that because this fraction is actually this plus this, so we can write that. Now you can put them 3 over x plus 2 dx minus integration 2 over x minus 5 dx. So you can put them this way. Now, one rule in substitution, we saw that one of the formula is integration of 1 over ax plus b dx by using the substitution rule. Okay, so you can come up with this one is 1 over a ln ax plus b, so plus c. So you can write this as a formula. Otherwise, what you can do is you can just use the substitution rule. Okay, using substitution rule, this is what you're gonna get using substitution rule. So you'll get that. Okay, I trust you that you'll be able to go from here to there, but I suggest please memorize this because it will save a lot of time, and we'll be using this over and over again. So you can verify that the integration of this equals this one, but I also hope that you will memorize this. Now, using that formula, so let us use this formula. Now this, you can actually write this 3 outside if you like, Okay, you can write that 2 outside if you like. We have already discussed that. So this is going to be 3 using this formula, 3 ln x plus 2, and then the coefficient of x is 1, so basically 1 over 1, so you don't have to write that. So basically just write 3 ln natural logarithm x plus 2 minus 2 natural logarithm x minus 5 plus c, done. This is what we're going to do. Okay, the idea is, if we are given this kind of little bit complicated fraction, and if the substitution rule and other rules fail, then we will change this into partial fraction like this. Okay, and once we change the partial fraction, then we'll be able to find the integration. This is the whole idea that we'll be practicing today. All right, guys? And we will be working with different kind, I mean, there are basically 3 cases, and we will go case by case. Okay. All right. Now, sometimes, first of all, remember, it's a rational proper fraction. So that's what we can do. Sometimes you'll be given improper fraction. This is your improper, because the degree of the numerator is 3, the degree of the new denominator is 1. So when the degree is in the numerator is greater, then we call it improper fraction. Improper fraction. Now, let me take you to elementary school just for few seconds, just for 1 minute, if you don't mind. In elementary school, if you are given 2 over 5, then okay, this is a proper fraction, you just leave it like that. Suppose if you are given 5 over 2, then I think what you were told to do is you need to divide, 5 by 2, right? So what you did is divide 5 by 2, right? So, and then 2 times 2 is 4. So you're going to get 1. So this 5 over 2 can be written as, this is your quotient is this is your remainder, and this is your divisor. So recall that in elementary school, you were told to divide and express in mixed number, which is always Q remainder by divisor in that form. So that means in this case, your quotient is 2, remainder is 1, divisor is 2. So that's how you write, right? Or if you want, you can write 2 plus, you can also write, instead of that, you can also write Q plus R over D. You can also write that. In another word, you can write Q2 plus 1 over 2. You can also write this way. So that is what you were told in elementary school. And in high school, you also learn how to divide it and change it into proper fraction, okay? Improper fraction. When the degree here, degree of numerator is greater than degree of denominator. So we carry out the long division. Carry out division. Okay. So in this case, long division. Recall from your high school. And now let's divide this. This 2x cubed plus 3x squared minus 2x minus 4. Let us divide this by 2x plus 3. Okay. So how do we divide? I trust that everybody know how to divide it. It's just like here, how you divide these numbers, 5 over 2. It's a little bit different, but the idea is pretty much the same. So first of all, we want to cancel this guy, which means we need to multiply by x squared. so that it will be 2x times x squared will be 2x cubed and plus 3x squared. So you can cancel, you change the sign and you cancel that. So you're left with negative 2x minus 4. And so now you will do minus 1 time, so that you're going to get negative 2x and negative 3. So this, change the sign, okay? So change the sign here. This will be positive, this will be positive, and so you cancel that out. Here remainder is 1. So this is your quotient and this is your divisor and this is your remainder. Now remember that this one can be written as this 2x cubed plus 3x squared minus 2x minus 4 divided by 2x plus 3 can be written as q plus r over d, just like that. So q is x squared minus 1 plus r is 1 divided by 2x plus 3. Okay, now you see this is so easy. Earlier it was like integration of 2x cubed plus 3x squared minus 2x minus 4 divided by 2x plus 3. It was so difficult to integrate, but now you can integrate so easily. So it will be x squared minus 1 plus 1 over 2x plus 3 dx. So you can just separate them, which is x squared dx minus 1 dx plus integration 1 over 2x plus 3 dx. Okay, yes, r is negative 1. I was checking how many of you are paying attention. Thank you, Istabrak. Yes, this is negative, guys. Okay, I was checking how many of you are paying attention. Good job. And now this one is negative 1, means it will be minus there. So this will be minus there. And so this is minus there. So now this is x squared dx. It's a piece of cake for you, which is x cubed over 3 minus, this is simply x, minus, now using the formula, recall the formula. So it will be 1 over 2 ln 2x plus 3 plus c. Done. This is your answer, because remember the formula. So integration 1 over ax plus b dx equals 1 over a, whatever is there, 1 over a ln ax plus b plus c. That is the formula, and I'm using that formula, and that's what I got. Any question, guys? Okay, if you don't have any question, then I have a question for you. Suppose you are given this example 2, let's say. Okay, example 2. 1 over x squared minus 7x plus 10. Because I try to use the substitution rule, it's not going to work. And simple, antiderivative formula is not going to work. So the only hopeful method would be partial fraction, changing it into partial fraction. Now, what will be the partial fraction for this? That's not easy to figure out, right? Can you tell me what will be the two partial fraction that you can find the integration easily? The goal is to change this given fraction into small chunks so that we can find the integration of those chunks easily, those small fraction easily. So what will be the partial fraction for this guy, for this fraction?
Do we need to factorize the denominator, right?
Okay, that's the first thing. Thank you. So if I factorize, so I'm gonna get This will be x minus 5 and x minus 2. Okay, x minus 2 and x minus 5. All right, and now I need two fractions there. So do you think 1 over x minus 2 and then plus or minus 1 over x minus 5, do you think this works? How do we figure that out? That's the thing we will be working now. Okay, we don't know, this may not work, you know, the number could be anything. So what we do is, let us suppose that this one will be a, the number will be a, so x minus 2, and then another number will be b and x minus 5, and our job is to figure out what is the value of a and b. And this is case one. There are 4 cases, guys. So case number 1 is the denominator qx is a product of distinct linear factors. So this one is linear factor. First, both of the factors are linear. Linear means the degree is 1. So if that is the case, always what you do is you write this way. You divide this into this form. A divided by the factor, one factor, plus b divided by the second factor. And now your job is to figure out the value of you know, a and b. So how do you do that? Well, let's do this. 1 divided by x minus 2 and x minus 5 equals, this guy will be x minus 2 and x minus 5. Just do high school algebra here. So you're going to get a times x minus 5 plus b times x minus 2. Okay. Now, the multiply both sides by x minus 2 and x minus 5. X minus 2 and x minus 5. So if you multiply that both sides, so on the right hand side you're going to get 1 only, and on the left hand side you'll get x minus 5 plus b x minus 2. Now all you need to do is you know, solve this equation and find the value of a and b. Now we need to find value of a and b. All right, guys. So there are a couple of ways to do that. So I'll do, to find the value, I will say method 1. So in method 1, what you can do is, you know, choose a value of x such that either a or b will be eliminated. Okay, in method 1, let us suppose that x equals 5, for example. In that case, this term right here will be 0. So that means a will be eliminated. Okay, use common sense here. So let us suppose that x equals 5. Then what happens is 1 equals, this guy will be a times 0. Okay, plus this will be b times x minus 2, means 5 minus 2, which is 3. This is your equation 1. And now you can solve. This gives you, what is the value of b? Well, it is 1 divided by 3. Right? Now, in the same way, we want to eliminate b this time. How can we eliminate? What value of x will eliminate b? Yes, thank you. So thank you, guys. So this one, x equals 2 will eliminate b. Therefore, I suppose x equals 2. Then this will be on the left hand side, it is 1 equals this a times x is 2 minus 5 plus this guy will be 0. So that your a will be negative 1 over 3. Okay, we got the value of a and b. That's method 1. Now method 2. So what we can do is equating the coefficient. So we can equate coefficient of x. So we can equate coefficient of x and figure out. Let me see what is given here is we have, okay, let me just copy the same question here. Let me copy that. So this is 1 equals, you'll get ax minus 5a plus bx minus 2b. Or I can write this as, or I can write 1 equals a plus b x and then minus 5a minus 2b. I can write this. Now, equating the coefficient means what we do is look at the right side. So in the right side, it is simply 1, okay? So what I can do is, I can write this as 0x plus 1. Can I write that? So that equating the coefficient, so the coefficient of x is a plus b. So therefore, what we get here is that a plus b equal to 0. Because coefficient of x is 0 there. So this 0 and a plus b must be equal. If the whole thing are equal, that means their coefficient must be equal. Okay, just using the high school algebra, keep that in mind. Now, and then what we got here is that the remaining, and negative 5a minus 2b equals 1. So we got equation 1 here and equation 2 there. Let me write this way. And minus 5a minus 2b equals 1. Now I want you to solve this two equation. This is equation 1, this is equation 2. Solving equation 1 and 2. So what do we get? We get a equals and b equals. Let me know what you get. Okay, a is 1 over 3, b is 1 over 3 after solving these two equations.
A is negative 1 over 3, Professor.
Okay, yes, I was checking how many of you are paying attention actually. So this is negative is this, not the other way around. This is negative 1 over 3. This is positive, b is positive 1 over 3. Okay, thank you. Now, so let us substitute the value. I need more space here. So what I can do is, let me go, you know what, I'm going to do this. I'm going to put all this 1. Let me push this all the other side. Okay, there we go. All right, so solution, what we got here is that integration of 1 over x squared minus 7x plus 10 dx equals a divided by x minus 2. Okay, integration of that. A is what? 1 over 3, right? Negative 1 over 3. Okay, so let me substitute that. So negative 1 over 3 dx plus this factor is, remember what we got here is that, so 1, let me just copy what we did. So we got 1 over x minus 2 and x minus 5, which is actually this one, equals, we got a divided by x minus 2 plus b divided by x minus 5. That's what we have, and we found the value of a. A means negative 1 over 3 over x minus 2 dx, and b is 1 over 3 over x minus 5 dx. All right, so you can actually write this in a nice way. It will be negative 1 over 3, 1 over x minus 2 dx plus 1 over 3, 1 over x minus 5 dx. So now, using the formula, this is negative 1 over 3 ln x minus 2 plus 1 over 3 ln x minus 5 plus c. Done. Any question? So when the factor in the denominator are linear factors, then this is the process that we do. Okay, and life is not that always easy. Sometimes the factor in the denominator are not that easy linear factors. Sometimes they will be, repeating factors. For example, let's look at this example 3, and I call it case 2. So the denominator qx is a product of linear factors, some of which are repeated. For example, in this example 3, x minus 1 is square. So both are linear factors, okay? But this factor is repeating, the power is 2. Then how do we do that? How do we change this fraction into partial fraction? What is the process? Okay, so to change this into partial fraction, this is the idea, okay? Let us suppose that 4x over x minus 1 is square and x plus 1 is square equals, if the factors are linear but some of them are repeated, then this is what we're going to do. A over x minus 1, okay, plus b over x minus 1 square plus c over x plus 1. Because in this, remember, this x minus 1 square and x plus 1, so there are 3 factors actually. So the one of the factor is x minus 1 itself, another factor is x minus 1 square, and another factor is x plus 1. So there are 3 of those factors that we can take it out from them, okay? So in that case, we will put this way. So all we need to do is, now we need to find the value of a, b, and c, okay? Now we need to find.
Excuse me, Professor.
Yes.
I do have a question.
Okay, that's a very good question, guys. So here, if instead of x minus 1 square, if there is cube, then what we have to do is we have 4 factors actually. We'll write a over x minus 1 and b over x minus 1 square plus c over x minus 1 cube plus d over x plus 1. So, we'll have 4 factors. Yeah. Now we need to find the value of a, b, and c. Which method do you like to find the value of a, b, c? So the first one or the second one? Maybe first one is easier in some cases, but some cases method 2 is easy. So here maybe I'll use method 1. Okay, now we need to find the value of a, b, c. So for which, what I'm going to do is, first of all, let me just simplify a little bit further. X minus 1 square and x plus 1 equals, I multiply both side by, if I multiply both side by x, if I multiply both side by x minus 1 square and x plus 1, I'm going to get 4x equals this bottom part. Remember, we multiply both side by x minus 1 square and x plus 1. That's what we're going to multiply both side. So if I do that, maybe I'll write here. So multiplying, because remember on this side, we just want the top part, the numerator only on the left hand side. So denominator must be canceled out so that we can compare the coefficient, or we can do the process that we did earlier. Therefore, in order to cancel this bottom, so just multiply both sides by x minus 1 square and x plus 1. Okay, so that you're going to get 4x on this side equals, this side will be a, and what do you get here? X minus 1 cancel, you're going to get x minus 1 and x plus 1. Okay, on this side, because I'm going to multiply this by this one. So one factor, x minus 1, is canceled, so you're left with that, plus b times, so x minus 1 square cancel out, so you're left with x plus 1, plus c times x minus 1 square. All right, now to find this, what you're gonna do is you can actually equate the coefficient, or you can do, you know, whatever you like. So in order to eliminate a, I will suppose let x equals 1. Then what do I get? On the left hand side, I'll have 4 times 1 equals, this will be a times, this will be, okay, the whole part will be 0. And this one will be b times 1 plus 1 plus this guy will be 0. So this gives me value of b equals 2. Okay, and in the same way, let us suppose that x equals 1, I mean -1, so that we can eliminate. So then what we get is 4 times -1 equals a times -1 minus 1, and then -1 plus 1. So that guy will be 0 actually. So this will be 0 plus -1. This also will be 0. And plus this will be c times x is -1 minus 1 squared. So if you simplify that, your value for c is going to be, is that -1? Yeah, that's -1. Now the question is, we found the value of b, we found the value of a. How do we find the value of, value of c? How do we find the value of a? Well, you can suppose any value, because there is no way that you can eliminate b and c and left with a. There is no such thing. So what we're going to do is, let us suppose, to make our life easy, you can suppose x equal to 0, you can suppose x equal to 10, you can suppose x equals to 100, 1,000, million, 10.5, whatever you like, you can suppose. But my suggestion is to make your life easy. So the easy number to deal with will be, maybe I'll suppose x equal to 0. Then, so what do I get here? 4 times 0 equals a times 0 minus 1, and this 0 plus 1 plus b times 0 plus 1 plus c times 0 minus 1 squared. And solve this and let me know what is the value. How much do you get? Okay, let's see. If I solve this, I'm gonna get 0 there, and this will be positive and negative. Negative a, and this will be plus b, and this is plus c. That's what we got. Now substitute the value. We already know the value of b and c. So substitute. Guys, so far we are doing all high school algebra. Okay, we are not doing any integration yet. So substituting value of b and c, we get, what do we get? 0 equals negative a plus b is 2 and c is minus 1, and that's going to give me a equals, I know some of you have already got the answer and put the answer in chat box, and thank you very much for that, and we got a equals 1. Okay, so hence we got the partial fraction, guys. So the partial fraction is 4x divided by x minus 1 square, and x plus 1 dx can be written as integration of a over x minus 1 dx plus b over x minus 1 square dx plus c over x plus 1 dx, and we already know the value of a, b, c. So a is 1 over x minus 1 dx. Okay, I'll leave it to you guys. So complete it by yourself, okay? So integration of 1 over x minus 1 using the formula that we discussed earlier, it will be ln x minus 1 plus this guy. Okay, so let us calculate how much is this. So we need to find 2, I can write outside, which is x minus 1 square dx. So you can suppose u equals x minus 1. Now, in this case, I think substitution rule works. Okay, so let us suppose that u equals x minus 1. Then your du over dx is going to be 1, which gives me du equals dx. So this guy will change into 2, 1 over u square du. So which means 2 u power negative 2 du. So that means u, and you already know how to find it. So u negative 2 plus 1 divided by negative 2 plus 1 plus c. And so we get this negative 2 and u negative 1. So if you substitute the value back, you're going to get negative 2 over x minus 1. That's what we got. Okay. So this guy will be, we just found, which is negative 2 over x minus 1 plus this guy will be ln x plus 1 plus c. Done. This is the answer. But if you want to go further, what you can do is you can actually write this as ln x. Is that positive or negative? Okay, hold a second. So anybody notice C is negative 1? I was checking how many of you are paying attention, and yes, you see, thank you. C is negative 1, so this is negative 1 there. So that's going to give me negative there, negative value there, and that's it. So if you want to be a little, if you are familiar with the logarithmic rule, you can write, or you can also write ln x minus 1 divided by x plus 1 minus 2 over x minus 1 plus c, because ln x minus ln y can be written as ln x over y. So remember that. So if you want to use that formula, go for it, and otherwise just you can stop there. So this is also fine. Okay, if you still remember your high school algebra or pre-calculus, then you can go one step further if you like. Okay, all right guys, any question? So let's try another type, case 3. When the denominator qx contains irreducible quadratic factors, none of which is repeated. Look at this example 4. So what we do in that case is, you see in this example, as you can see here, there is x minus 2, but there is one quadratic non-reducible, x square plus 1. You can do nothing. You cannot reduce it further. X square plus 4, you cannot reduce it further. So in that case, what do we do? So we'll look this kind of, one example here, okay? But before we start, I just want to remind you one formula. That integration of 1 over x squared plus a squared dx equals 1 over a tan inverse x over a. So this formula will be given to you. If you memorize, great. If not, then this will be given to you. Okay, don't worry. Whenever you see these kind of expression, just use the formula directly. You don't have to do anything. Now, in this example, let us look at that. The power is 2 there. The degree is 2 in the numerator. Degree is 3 in the denominator. So this is a proper fraction. We don't need to do the division. Okay, the top part is smaller than the bottom. So no division. Let me just copy that. 2x squared minus x plus 4 can be written as over x times x squared plus 4. Okay, now there is one quadratic non-reducible factor, x squared plus 4. If x squared minus 4, you can reduce it, x minus 2 and x plus 2, but you have x squared plus 4, you cannot reduce it. So in that case, what we need to do is, okay, this is the standard procedure, okay? Whenever there is this square quadratic form, then this one is linear. For linear, we just write a, no issue there. We already know that, okay? X or x minus 1 or x plus 1, doesn't matter. They all are linear. So we just write a for that. Now, for this factor, we have this x squared plus 4. Then what do we do? Well, in that case, if the bottom part is quadratic, then the top part will be linear, which means you can write bx plus c. Okay, when there is power 2, there is power 1. When there is power 1, there is power 0, by the way. 1 less. Okay. This is all we need to do. Our job is to find the value of a, b, and c. That's it. So multiply both sides by x times x squared plus 4, and let's see what happens. Okay, and all we need to do is we need to find the value of a, b, and c. Let us, you already know two methods, but here I want to use to find, I can write this as this way. Let me just rewrite this once more. 2x squared minus x plus 4. And if I put them nicely, x squared and, okay, this can be written as ax squared plus 4a plus bx squared plus cx. So I can write this as x squared common. So I'm going to get a plus b x squared and then plus cx plus 4a. Okay, now comparing the coefficient of x squared, x and constant term, maybe you just write comparing the coefficients. So what you're going to get is, you see, x squared coefficient is a plus b and x squared coefficient is 2. So that means you can write a plus b equals 2. This is your equation 1. And here you have x and here x. So that means the coefficient is 1 there. So that means C is -1. This is your equation 2. And then the last one is, let me write this way. C is -1 and 4a is 4. Okay, 4a, constant and constant, they are equal. So a gives me 1, c is -1, and then from this one you can get 1 plus, substituting the value, 1 plus b equals 2. So it's going to give me b equals 1. So we get a is 1, b is 1, and c is -1. Now all you need to do is just substitute the value and you can complete that by yourself. Okay, here the only difference is that when this is non-reducible, like quadratic but non-reducible, then all you need to do is, instead of b, you need to write bx plus c. You need to write a linear factor on the top. That's one thing you need to remember. Let me repeat this. This is the main thing for this one. Okay, after that, all the other steps are pretty much the same as we did before. So whenever the fraction, the rational fraction has this quadratic non-reducible factor, then what you need to do is, you need to, instead of supposing b divided by that, you need to write bx plus c as we did here. That's all. Now I want you to complete this yourself. Integration 2x squared minus x plus 4 divided by x cubed plus 4x dx equals, you can write down this as okay, a over x dx plus bx plus c over x squared plus 4 dx. All right, so now substituting the value, you can write a means 1, so you'll get 1 over x dx plus bx plus c. B is 1, x plus c is -1. Okay, -1 over x squared plus 4 dx. Now this one you already know, which is ln x, but for this one substitution rule is not going to work. What you can do is just use common sense, guys. What you can do is x over x squared plus 4 dx, we can write that, minus 1 over x squared plus 4 dx. We can just put them separately. Okay, just put them separately. Now all you need to do is, you need to find the integration of these two guys. Now let me just do it here and we just copy and paste. Okay, integration x over x squared plus 4 dx, and I want you to use the substitution rule. Let u equals x squared plus 4, then what? Then du over dx equals 2x. So du over 2 equals x dx. So in order to evaluate that integral, what we have is x dx means du over 2, and that is 1 over u du over 2. That's what we got. So that means 1 over 2, and this is actually ln u, right? So substituting the value back, half ln u means x squared plus 4. Okay, so that part is done. Let me just copy that, which means this is ln x plus this one is half ln x squared plus 4 minus this guy will be, oh, you see, this one is just like we have seen the formula, right? So what the formula that we just talked earlier is 1 over x squared plus a squared dx equals 1 over a tan inverse x over a. That is the formula. So if I ask you 1 over x squared plus a 2 square, because 4 means 2 square, dx, then this is pretty easy, right? So a means 2, so substitute a 1 over 2 tan inverse x over 2, that's it. So let me just copy that down here. So that's going to be negative half tan inverse x divided by 2 plus c. That is your answer. All right, guys, so this one, forget about this. It will not be given in the exam, but if we have time, we can actually, try to do it just for fun, but at this time, we'll skip, okay?